Good morning everyone. Today we are going to discuss about an important topic, that is vibration. So the reason for saying important is most of the engineering applications, they are being dealt with vibration. So this is one of the major issue. So the reason for studying this vibration is to reduce this vibration, because it is difficult for us to eliminate the vibration, but it is easy for us to reduce the vibration. So before knowing about the different types of causes, first we are going to know deep about the vibration. So vibration, so let's consider an elastic object like a spring, shaft. So these are the elastic object. So when you are giving external disturbance, so because of the application of external force and then it is released, it oscillates about an equilibrium position. So that is called as vibratory motion. And next we are going to discuss about the important terms involved in vibration. So first one is time period. So time period is nothing but the time interval after which the motion repeated itself. So the time period is represented in terms of seconds. Second term is cycle. Cycle is nothing but it is the motion repeated after one time period. Motion repeated after one time period. So the third important term is frequency. This is very much important. So we need to determine the frequency of each and every external force as well as the frequency of each and every object. So frequency is nothing but number of cycles per second. So the unit of frequency is hertz. So the next we are going to discuss about types of vibration. So first one is free or natural vibration. Second one is forced vibration. And third one is damped vibration. So next we can see this in detail. So first we are going to discuss about free or natural vibration. So as the name itself indicates, so it is going to be free. In this case, there will be no external force that will be involved. But the thing is, there will be initial displacement. So initial displacement will be given to the system, and because of that the object will be vibrating about a equilibrium position. And in this case, the frequency of free vibration is natural frequency. And the second one is forced vibration. So as the name itself indicates, we are going to give vibration because of some external force. So in this case, external force or disturbance is involved. And the next thing is, so the vibration will be taking place until the force is given to the system. And the external disturbance is mainly because of the unbalance in the system. So this is about forced vibration. And third one is damped vibration. So damped vibration is nothing but, in this case, the amplitude of the vibration reduces over each cycle. So for reducing the amplitude, we'll be providing a device that is called as damper. So this damper will provide friction to the object. So because of that, there will be reduction in the amplitude. So next we are going to discuss about types of free vibration. So first one is longitudinal vibration. So second one is transverse vibration. And third one is torsional vibration. So these are the three different types of free vibration. So first we are going to discuss about longitudinal vibration. So I'm going to consider a weightless constraint, either it can be shaft or spring. So in this case, the shaft has been fixed at one end and the other end where the heavy load or disc has been placed. So in the longitudinal vibration, I'm going, sorry, the shaft is fixed at one end and it consists of disc at the other end. In this case, the particle on the shaft or spring will be moving perpendicular to the axis of the shaft. So these two represents the movement of the disc. In this case, the shaft will be elongated and it has been stretched alternatively. So in this case, the stress that has been induced is tensile stress and compressive stress that takes place alternatively in the object or in the system. Second one is transverse vibration. So in this case, I'm going to consider the same constraint with the heavy mass at the other end. So in this case, the shaft will be oscillating perpendicular to the axis of the shaft. So either the shaft will remain straight or will be moving perpendicular. So in this case, the stress that has been induced is bending stress. So third one is torsional vibration. So the same constraint which is fixed at one end and consists of heavy disc at the other end. So in this case, the particle of the shaft or spring will be moving in a circle. So it will be moving from A to B. So in this case, the shaft will be twisted and untwisted. So the stress that has been induced is torsional shear stress. So these are the three different types of vibrations with respect to the free vibration, and there are different methods that has been used to calculate the frequency of the longitudinal as well as the transverse vibration. So this is the formula that is used to calculate the frequency of longitudinal as well as transverse vibration, that is 1 by 2 pi root of S by M, or frequency is equal to 1 by root of G by delta. So this can be written as 0.4985 root delta. So delta is nothing but deflection due to load. S is nothing but stiffness. Then M is nothing but mass. G is acceleration due to gravity. So this is the important formula for calculating the frequency of longitudinal as well as transverse vibration. So the next important case we are going to discuss is about the frequency of transverse vibration on a shaft subjected to number of point load and UDL, that is uniformly distributed load. So there are different methods that has been available to calculate the frequency for this condition. So I am going to discuss about the Dunker-Lee's procedure to calculate the frequency of the given shaft. So I am going to consider simply supported shaft with the point load W1, W2 and W3, and I am going to consider a uniformly distributed load on the shaft. This uniformly distributed load can also be said as the mass of the shaft. So we can say that we are going to consider the mass of the shaft. So in this case, so because of this W1, the deflection that has been created is delta 1, and for the load W2 the static deflection is delta 2, and for load W3 static deflection is delta 3, and it continues. So this is like by considering the weight individually. So rather than considering all the weight, by considering assuming that the shaft contains only the weight W1, in that case the static deflection will be delta 2, and the shaft when it contains W2 the static deflection will be delta 2. The shaft which contains W3 load alone, in this case the static deflection will be delta 3. So this is static deflection, and delta S is nothing but static deflection due to UDL or mass of the shaft. So I am going to derive the formula for calculating the frequency for this condition. So the formula will be like 1 by Fn square divided by 1 by Fn1 square plus 1 by Fn2 square plus 1 by Fn3 square, so on to 1 by Fns square. So Fn1 is nothing but the frequency due to the load W1. So it is 0.4985 divided by delta 1. Fn2 is 0.4985 delta 2, and Fn3 is 0.4985 divided by delta 3, and Fns is equal to 0.5615 root delta S. So these are the terms. So we are going to substitute all these terms in the equation. So which is equal to 1. So delta 1 divided by 0.4985 square plus delta 2 divided by 0.4985 square plus 1 delta 3 divided by 0.4985 square, so on to delta S divided by 0.5615 square. So in this case we are going to take 0.4985 square out from all the equations. So 0.4985 square, which is equal to delta 1 plus delta 2 plus delta 3, so on to delta S divided by 1.27. So this is formula for this equation. So it can be further simplified. So finally we'll be getting, so frequency square is equal to 0.4985 square divided by delta 1 plus delta 2 plus delta 3 so on to delta S divided by 1.27. So we need only the frequency. So this will be coming as a root in the other side. So 0.4985 divided by root delta 1 plus delta 2 plus delta 3 so on to delta S divided by 1.27. So this is the formula for calculating the frequency of the transverse vibration while considering the point load as well as the uniformly distributed load. So there will be certain conditions where this formula can be further reduced when the mass of the shaft is negligible. In this case, delta S will be equal to 0. So formula is frequency is equal to 0.4985 divided by root delta 1 plus delta 2 plus delta 3 and so on. And there is the formula for calculating delta 1, delta 2 and delta 3 for simply supported beam. Simply supported shaft. So the delta is equal to W A square B square divided by 3EIL. So thank you. Good morning, student. Today we are going to discuss a problem from vibration. So in this problem, we are going to determine transverse vibration of the given shaft. So first I'll read out the question. So from the question, we can understand what are the data that is given. A shaft 50 mm diameter. So shaft diameter is given. It is 50 mm. So we have to convert this in terms of meter. So it will be 0.05 meter. And the next it is given as it is 3 meters long, is simply supported at the ends and carries 3 loads of 1000 Newton, 1500 Newton and 750 Newton at 1 meter, 2 meter and 2.5 meter from the left support. The Young's modulus for the shaft is 200 giganewton per meter square. So we are going to determine the frequency of transverse vibration. So the diameter is given. So diameter is 50 mm. So we have to convert that in terms of meter. So it will be 0.05 meter. And the next thing that is given is length of the shaft. So length of the shaft is 3 meters. So already it is given in meters. There is no need to convert that in terms of meter. And the next thing, there are 3 loads that has been present in the system. So the first load, it is represented as W1, which is 1000 Newton, and W2, which is 1500 Newton, and the third load is 750 Newton. And the next thing that is given is Young's modulus. So Young's modulus, it is represented as E. So E is equal to 200 giganewton per meter square. So we need Young's modulus in terms of Newton per meter square. So we have to convert this into Newton per meter square. So it is 200 into 10 power 9 Newton per meter square. So we are going to calculate the frequency of the transverse vibration. So first I'll write down the formula for calculating the frequency of the transverse vibration. So frequency of the frequency, it is represented as Fn. So based upon the Dunkerley's principle, we are going to calculate the frequency. So frequency is equal to 0.4985 divided by root delta 1 plus delta 2 plus delta 3. So delta 1, it is the deflection due to the load 1000 Newton, and delta 2, which is nothing but the deflection due to the load 1500, and delta 3 is nothing but the deflection due to the load 750 Newton. So based upon the given data, we are going to draw the diagram. So since it is given like it is a simply supported shaft, so I'll draw the diagram first. So simply supported shaft. So I'm going to represent the end as A and next end as B. And it is given as the load W1, which is equal to 1000 Newton. It is acting at a distance of 1 meter from the left support. and the next load, which is represented as 1500 Newton, so which is at a distance of 2 meter from the left support, and the third load W3, which is 750 Newton, it is at a distance of 2.5 meter from the left support. So these are the data that we have, based upon the data we have drawn this diagram. So next important thing is we are going to determine the delta 1, that is delta for each and every load. So before moving towards the formula, so before moving towards the sum, we can write the formula for calculating the delta. So delta is nothing but W A square B square divided by 3EIL. So this is the formula that is used to calculate the deflection for each and every load. So based upon the load, the deflection will be varying. So in this data, the important thing is the value of I. So first we can calculate the value of I. So since it is the circular shaft, so the formula will be pi by 64 d power 4. So it is pi by 64 into d value, it will be 0.05 power 4. I is equal to pi by 64 d power 4. So pi by 64, the value of d is, it is 0.05 power 4. So we can calculate the value of I. So the value that we are getting is 3.06 into 10 power minus 7. So the unit for I will be meter power 4. So we have calculated the value of I. So the next thing we are going to calculate is delta 1, that is deflection due to the load 1000 Newton. So I'll assume that the simply supported beam consists of only the load 1000 Newton. So with that data we can able to calculate the value of W1. So this is point A, this is point B, and the distance of the load from the left support, it is given as 1 meter. So the total length of the shaft is 3 meter. So this remaining distance will be 2 meter. So we know the formula for calculating delta. So delta 1 is equal to W1 A1 square B1 square divided by 3EIL. So in this case, the A is nothing but the distance of the load from the left support. So it will be 1 meter, and B will be the distance of the load from the right support. So in this case, A will be 1 meter and B will be 2 meter. So we can substitute this in the formula. Since we know all the values, we can easily calculate the value of delta 1. So delta 1 is equal to W1 will be 1000 into A1 is 1 square, B1 is 2 square divided by 3 into E will be 200 into 10 power 9. So I, it is 3.06 into 10 power minus 7, and L will be 3 meters. So we can calculate the value of delta 1. So 1000 into 1 square into 2 square divided by 3 into 200 into 10 power 9 into 3.06 into 10 power minus 7 into 3. So this will be the value. So value of delta 1 will be 7.262 into 10 power minus 3. Since the value of the unit of deflection will be meter. So next we are going to calculate delta 2. So delta 2 is the deflection due to the load 1500 Newton. So for this, in this case, now we are going to assume the simply supported beam which consists of only this load, that is the 1500 Newton. So with that data, it will be easy for you to calculate the value of delta 2. So first I will draw the diagram. Lift support, sorry. So W2 will be 1500 Newton, and this distance is 2 meter from the lift support. It is given in the question. And 1 meter from the right support. In this case, the value of A will be 2 meter and value of B will be 1 meter. In this case, the value of A will be 2 meter and B will be 1 meter. So we know the formula. We are going to use the same formula, that is delta 2 will be equal to W2 A2 square B2 square divided by 3EIL. So we know all the values. So W2 will be 1500, A2 is 2 meter, B2 will be 1 meter divided by 3 into 200 into 10 power 9. So you know the value of I is 3.06 into 10 power minus 7, and the value of L will be 3 meter. So we can calculate this. So 1500 into 2 square into 1 square divided by 3 into 200 into 10 power 9 into 3.06 into 10 power minus 7 into 3. So it will be 10.86 into 10 power minus 3 meter. So value of delta 2 will be 10.86 into 10 power minus 3 meter. So next we are going to calculate the value of delta 3. So delta 3 will be because of the load 750 Newton. So in this case we are going to assume that the shaft consists of only this 750 Newton. So first we can draw the diagram considering this load alone. So this is left support and this is right support. W3 will be equal to 750 Newton. So distance it is given as it is 2.5 meter from the left support. So the remaining distance will be it is 0.5 meter. So in this case A will be equal to 2.5 meter. So we know that A is nothing but the distance of the load from the left support, and B will be nothing but the distance of the load from the right support. So B will be 0.5 meter. So we know the formula. So delta 3 will be equal to W3 A3 square B3 square. So we have calculated delta 1, delta 2 and delta 3 value. So from this we are going to determine the frequency of the transverse vibration. So frequency is equal to 0.4985 divided by root delta 1 plus delta 2 plus delta 3. So delta 1 is 7.24 into 10 power minus 3 meter. So delta 2 is 10.86 into 10 power minus 3 meter, and delta 3 is 2.12 into 10 power minus 3 meter. So we can substitute all these values in the frequency formula. So frequency is equal to 0.4985 divided by delta 1 is 7.24 into 10 power minus 3 plus 10.86 into 10 power minus 3, this point, then 2.12 into 10 power minus 3. So first we can calculate the denominator value, then we can divide the numerator and denominator, and we can calculate the frequency. So 7.24 into 10 power minus 3 plus 10.86 into 10 power minus 3 plus 2.12 into 10 power minus 3 root of this value. So it is 0.1421. So by dividing numerator and denominator, the value that we'll be getting is 3.5 Hertz. So this is the way by which we can able to determine the frequency of the transverse vibration. So I'll quickly go through what are the things that we have discussed in this problem. So with the help of the given data, we have written all the given data, and we have drawn the diagram with the help of the given data. And the formula that we have used is two formula. One formula is the delta formula, that is delta is equal to W A square B square divided by 3EI. So this formula. And the next formula that we have used is frequency formula, which is equal to 0.4985 divided by root delta 1 plus delta 2 plus delta 3. And the last formula that we have used is formula to calculate I is equal to pi by 64 d power 4. So the important thing that we want to note is, in this case it has only 3 point loads. So that's why we have used delta 1, delta 2 and delta 3. We have not considered the weight of the shaft. If the weight of the shaft is need to be considered, means the formula will be entirely different. Thank you.